Alright guys, welcome back to the Derv Codes channel. Today we're going to be solving LeetCode number 1 to sum. Problem states that given an array of integers nums and an integer target, we want to return the indices of the two numbers such that they add up to the target. We can assume that each input has exactly one solution and we can't use the same element twice. So we can also return the solution in any order, which is important. So let's just say we had the target 7, or let's just say we had a target 8 and maybe an array just the array 4. Okay, target is 8. We couldn't use 4 twice because that's against the specifications. Okay, so to solve this problem, what's important to note is that whenever we have a sum of two values in the array that are not at the same index, there will be a pointer to one index, so A, and a pointer to another index, B, where A is less than B. And we know that this is always true because it can't be the same index, and one index must come before another index since we have a solution every time that adds up to our target. Right, so in this case, the value of A over here is index 1, and then the value of B over here is index 4. Okay, so what we know now is that if we consider from index 4, we want to look for another value such that 5, so the value at index 4, plus some other value adds the target. We just have to consider the array before it. Okay, so then we have a property that actually generalizes, which is that value of B, all we have to do is just search the array before it for the other index that has the element which, when added with 5, produces a target 7. So essentially, if we kept, let's just say, some sort of set that keeps track of these values before some index in the array, and we search that set now for the other values, so we were searching for 5 plus some value A, which is equal to 7, we know that A will be 7 minus 5, or generally A is equal to 7 minus B. Okay, so let's talk about what the algorithm will look like here. So since we know that the array at index A plus the array at index B is equal to our target, we can just look through the array for our B indices essentially. So we'll say this is a potential B index. So what we're going to do here is keep a visited hash map mapping the element to its index in the array. Since there's a unique solution, what's important to note is that there will not be any duplicates in terms of the output value, so it doesn't really matter if we update some value in the hash map with some different index if there's duplicates present. Alright, so let's look at potential values of B. So in this case, 1 can be a potential value of B. So if we have visited hash map, then at this point it's empty. So we know that when looking for our other value that when added with 1 is equal to the target, we know that it doesn't exist just because there are no values in the visited set. Okay, so what about at index 2? Well, now what we'll do after we've finished looking at index 1 is we'll add it to our visited set. So 1 will map to index 0 here. Okay, index 2, well, we know that we need a 5 just because 2 plus 5 is equal to 7. So we need a 5 over here, but it doesn't exist in the visited set. Well, then we just add 2 to the visited set with index 1. And then we update 10, same thing. 15, same thing, until we get to 5, which is our actual value of B, and we get to 5. Well, now we know that we need the value 2 because 5 plus 2 is equal to 7, and then we have it in the visited set and its index, so then we'll just look up the index of this value and add it to a list. So in this case, we just add 1 to the list, and then we add the index of this last element, which is 4. And then we know that this is a solution then. And that's essentially the whole algorithm. Since we're guaranteed a solution, that means we're guaranteed a b value, and thus this algorithm will always work. This algorithm takes O of n times, since we only traverse the list once, and O of n space, since the map can contain at most n elements. Guys, and now for the code solution. So what we want to do is begin by creating our visited map. Alright, and then we just want to iterate through the nums arrays. So for I in range, length of nums, what we want to do is we want to check if the element, so the value of a that I mentioned earlier, if that element is in the visited map, so that we could return the index. So we want to check if the target minus this value is in the map. So if this is in our visited map, then what we want to do here is we just want to return the array of the value I, as well as the visited at index target minus nums at index I, so that other value in the array. Okay, and then otherwise, so if we haven't found other values, so we've yet to find b, all we want to do is add the current element into the visited set. So visited at index nums at index I is equal to I in this case. That's all that we want to do essentially, because we're guaranteed a solution, so this condition is always guaranteed to fire. Alright, so now we can just submit the code, and as we can see, the solution passes and it is optimal. Alright, thank you guys so much for watching. I'll catch you in the next video.